very good morning. Welcome to Main and 5WA channel in very interesting session on data science. We all know like the talk of the town today is about data science, and it's got so many perspectives to confuse people because most of the people, if you're not born on the data science era, you would have come across so many terminologies like data mining, data warehouse, big data, machine learning, and then data science. For people who are starting out, have less confusion because they really start on the data science. So data science has got a lot of terminologies, statistics, it's got domain expertise, data engineering, visualization, advanced computing. So all of them make data science. So for example, if there is an OEM who has to build a product on data science, so he had to first build his infrastructure capabilities because you have to have a lot of ways by which the data can get processed. On the top of it, the engineering part on how do you classify the data, how do you retrieve the data, how do you query the data, you need to have that part of it very strong. Of course, the most important component is your algorithm part. Algorithm falls in a lot of spaces on statistics because you're talking about really breaking the data and looking at different patterns to it. So statistics definitely helps you there. So somebody who's coming from a domain expertise, maybe from an industry as well as statistics, might be a very good fit there. Last but not the least, the most important component is what the user sees, what the customer sees about visualization. So data science has got various perspectives from a high level. If you really break down this into seeing what Wikipedia tells, right? So it's a very good starting point for anybody. It's an interdisciplinary field. Okay, it uses scientific methods, processes, algorithm and system to extract knowledge, right? And you can have insight from many structured and unstructured data. So it's also related to data mining, machine learning and big data. So you'll see a lot of terminology used here. It unifies statistics, data analysis, there's another terminology. It uses different techniques of mathematics, statistics, computer science, domain knowledge, information science. Okay. So the Turing Award winner Jim Gray imagined data science as a fourth paradigm of science. Basically, it's empirical, theoretical, computational, and now data driven. So that's a very interesting perspective for all of you to know from what all the various things we talk about the history. It's good for you to go through that. A lot of careers which are there in the data science, maybe a machine learning scientist, okay, how they can really create new methods of data analysis and create algorithm. There's a data engineer, maybe you can design, build, integrate data from various sources. There's data analyst, there's data consultant, data architect and application architect. So these are some of the roles which are available, which really makes it very attractive. A lot of techniques like linear regression, logistic regression, decision trees, support vector machine, clustering, dimensionality reduction. All these are all different algorithms and techniques which you use within a data science paradigm. Different languages can be used to program: Python, R, Julia. Okay, Julia is something which is not well heard, but I think I'm sure all of you know Python and R. There are a lot of frameworks available. So when you're starting out on the data science world, you might want to really use a framework like TensorFlow, PyTorch, Jupyter Notebook, Apache Hadoop, blah, blah, blah. Okay. A lot of visualization tool. I think one of the very famous, which everybody knows, is about Tableau, Power BI. Okay. They're all very famous one. You have a lot more in the market. A lot of platforms are also available now. Anaconda is a platform. MATLAB is a platform. Databricks is a cloud platform, massive scale data engineering. Okay, you have Anaconda, which comprehensive free and open source distribution of Python and R. Okay, Rapid Miner is a data science software. The reason why I want you to go through this is it gets you a very good beginning page. So similarly, if you try to log in into any of your OEM cloud, for example, if I log in into AWS cloud, okay. So what happens here is moment you're trying to log in here, I will log in into my account. So you'll see that there are a set of products which Amazon will provide you, which becomes something which you can really use to develop a data science. Now you need to understand whatever we spoke about could be something which is outside cloud, but when you get into a cloud provider, you might see that you're using something which is relevant to the cloud service provider functionalities which can also be utilized. So for example, when you log in into AWS, for whatever we spoke about infrastructure, the compute will give you that infrastructure. You will find a lot of options for you for security here, for data science. You will find storage options here. And then when you come down like for machine learning, so a lot of this data science will come under machine learning here. Some part of it comes under database here. Basically the mix and match of services available across for you to build solutions on the Amazon. So similarly, if you log in into Google Cloud, Azure Cloud, Oracle Cloud, you'll find that there are some kind of infrastructure and tools apart from what's listed in the Wikipedia. So that's a nutshell about data science. It's a huge opportunities available for people. Really, it's a place to be in for the next 10 years, right? Now let's just continue brief about what is data science. Now data science in the data economy is very interesting because dashboards are seen at the top level, and then you can see that this is an example from Oracle. Like you could see that there is right hand side there is a lot of data method, data management, migration. Then you will find like there are executive dashboards which have been created, business transformation, cloud analytics. So it's in a basically we are trying to talk about, I think we have heard of 1,000 times about data is the new oil. So you're trying to create this data science patterns by using different part of the deck which we just saw, right? So what we saw about all these things, right? Similarly, the challenges in really what we have seen in this particular area is you'll find that people who are good in coding may not be good in mathematics and statistics. So you definitely need a mixed set of people here, right? A nerd is somebody in the intersection of a math, statistics and coding. So busy in financial service, preparing the next financial crisis, blah, blah, blah. And then you see business knowledge. So different learning capabilities required. You will find that data scientist is going to be really a job which is going to be awesome for the future. Okay. And I have seen that a lot of organizations look at like if you have existing people on the bench, people who are available from data warehouse team, they may not be always a good fit for data science. So you need to have a flair. For example, if you have a crisis or something on an airline industry, right? Basically, the data scientist will have to wear different hat. Basically, he has to understand the industry, he has to see the data, he has to identify a pattern, he has to mule a pattern in terms of what can be done to really create those algorithms. So it's just beyond simply trying to import, export data, run an ETL algorithm. So let's not generalize. Even a person who's very a graduate hire or somebody who can be 25 years, both of them can fit here. It depends on the flair for trying to understand the data science challenges, which are slightly different from how you would have operated a regular operational data warehouse or a ETL. So this is about a big data journey. I'm not getting much into it, but if you see an era which was there before data science was on the big data, where there could be streaming data coming in, there's a lot of volume of data, velocity of data, variety of data, then you store the data in the data warehouse, create veracity of value to what the customer needs. So that's what was the world in the past. So there are different people who will work on a data science project. So personally, since I've executed a couple of projects, you will have data scientists, you will have practice leaders, you will have an IT admin, operational guys. So if you really see, the role of these three people are slightly different. Like data scientists will use Python, R libraries, easily automate, share, deploy code. Practice leader will deliver more workloads, work with new team members. IT admin guy will leverage the Hadoop instrument, blah, blah, blah. Okay. So data science typically will look at data architecture, machine learning, analytics, three parts. So data architecture could be like Hadoop. Machine learning could be Mahot, Veka, Spark, MLib. Analytics could be using the R and Python. So that's the category of different things which you do it on the data science. For people who are very new, machine learning can be divided into different parts, categorized in continuous, unsupervised, supervised. You can see that there's different quadrants. And if you really look at supervised machine learning algorithm, we're talking about regressions, decision trees, random forest. Unsupervised is about clustering, dimensionality reduction, SVD, PCA, K-means come there. And then there is categorical things like association analysis, the a priori and FP growth, hidden Markov model. So why this list is because if you really go back to the journey of statistics, probability distribution, all this learning, and then you'll hear all these terms. Now you need to know how you can automate these things within the data science, or you will have to use something declaratively to select these algorithms on demand. Okay, but knowledge of this is a must for people who want to get into the data science. So some of the top algorithm which we use in data science is what we will cover a brief so that we have some understanding. One is a decision tree. So as the name suggests, you can think about this slide for a while. As the name suggests, decision trees, example is very easy. Like if you have a training data like this, like you have different records, different age, different income, student, credit rating, whether they are going to buy a computer or not, right? Now you need to make a decision tree. This is the training data. So you are putting a step one where telling like if it's a student, yes or no, can be the first decision tree you're trying to build. Okay. Then you might build, if it is a student, then the income is high, medium or low. That's a step two. Then you can also build the student, no, income, high, medium, okay, and then you tell medium yes, high yes, blah blah blah. Okay, you're categorizing it further. And you can go on and on. So decision tree is basically dividing this content or the entire data into various parts to really go to the leaf. Okay, and finally you might be able to make a pattern out of it. So this can be the most complex pattern in step 6 where you have gone very deep into it. So you can classify the different routes on how you want to really look at it. So that's decision tree for you. Now you might not want to write your random logic. So what you might do here is, what you're seeing here, you might have an algorithm, make use of those algorithms to really automate things. Okay, that's decision tree for you. The second algorithm which we commonly use is the random forest. Now random forest is basically you're very indecisive about watching a movie. For example, it's Edge of Tomorrow. You can do one of the following. Either you ask your best friend whether you like the movie, or you can ask your group of friends. Right? So what does random forest do? Ask your best friend and he thinks about, is it based on true incident? No, you will not like the movie. Does Emily Blunt star in it? Is she the main lead? No, you will not make. Yes, you like the movie. So you start getting randomly some questions and then you move into making a decision. But your best friend may not always generalize your preference very well. In order to get, you would like to ask a bunch of friends. Okay, now you can see this very commonly about when they take some surveys on census, right? Friend, different friends, and then random forest. Random forest is an ensemble classifier made using the decision tree model. Okay, combine the results from different models. The result from an ensemble model is usually better than the result of one of the individual models. Suppose you want to really look at like whether this product is really going to be going well. Instead of asking a single customer, you might apply this model to 1,000 people and then average it out or really look at the patterns. Third is the association rule mining, which is also which items are frequently purchased together by my customer. For example, shopping baskets, customer 1. So this is what a market analyst wants to do. So what association rule mining is doing is a well-researched discovering interesting relation variables in large data. For example, if you really look at the sales data of a supermarket, could indicate that if a customer buys onions and potatoes together, he or she is likely also to buy a hamburger meat. Just it might be a veg or non-veg. No, we need to really think about that. So number of records containing both A and B by the amount of records. Okay, the confidence of A to B could be number of records A and B, number of containing A, something like that. Okay. The next commonly used algorithm could be linear. The reason why I'm picking up some algorithms is what you do as a data scientist is slightly different to how you have written code in Python to write a data connector, retrieve data from the UI, store the information, apply some data mining. This is a little bit different because you need to know the statistical part of the things. So linear regression helps how value of dependent variable changes when any one of the independent variable changes, okay, while the other independent variables are kept fixed. This is the most popular algorithm used for prediction and forecasting. Now that's another algorithm. Similarly, you have something called k-means clustering. Okay, k-means clustering is what? You have total population, then you're dividing it by groups, group 1, group 2, group 3, group 4. A process by which objects are classified into number of groups. They are as much dissimilar as possible from one group to another group, but as much similar as possible within each group. Okay, that's what you do in k-means clustering. So objects in group 1 should be similar as possible. There could be much difference between objects in different groups. The attributes of the objects are all determine which object should be grouped together. Okay, so that's another algorithm. So these are some of the commonly used algorithms in data science. So if you really want to get started on data science as a career, you might want to really build your strong foundation on database, strong foundations on basically the data warehouse, data mining at the top level. Have some knowledge on the statistics, mathematics, algorithms, blah blah blah, and then start getting into the world of data science. But you need to be curious. I see some soft characters which are also important apart from knowing facts. You need to be curious, you need to be able to be interesting, to intuitive, to find some patterns. You need to be really looking very energetic because you can't really have a linear thinking in these kind of field. Okay, so all the best. So this is one of the most recommended career for the next 10-15 years. You will hear different names coming. Data mining might be called something else in 3 years, but a fantastic area to build your career. Thanks for watching.